Hello, Memphis. This is a math affair, and today we are simplifying surds. In our introduction video, we talked about what is a surd and the laws of surds. And I'm just going to go through a quick rundown of our laws of surds. The square root of a times square root of a returns a. Our multiplication law says the square root of a multiplied by the square root of b is the same thing as the square root of a times b. So you can put them both under the same root sign, multiplying, or you can separate them into single roots, still multiplying. Going for division, our law of division says the square root of a divided by the square root of b is the same thing as the whole square root of a over b. These are our main three laws of surds we are going to be using in simplifying surds and in all our lessons on surds. Our focus is on simplifying. What do we mean by simplifying a surd? Simplifying surds just means we're going to break down the surd, if it is possible, to a much simpler format. So you might start up with the square root of some number, let's say some number n, and what you want to achieve at the end of the day is something like this: k multiplied by the square root of b, where k is going to be an integer, right? This is going to be an integer, and our square root of b is still a surd, but at least it's a surd that is smaller than square root of n. It's a surd that is smaller than what we started with. So this is how we simplify surds. Let me illustrate with square root of 20. If I was to simplify the square root of 20, I would end up with 2 root 5. The question is, how do I come from square root of 20 all the way to 2 root 5? All right, so let's key in with our method. We are going to take advantage of this law right here. In our questions on simplifying surds, you're going to most likely be using the law of multiplication. So let me start up with that square root of 20 and explain to us exactly how we get this done. You're going to look for 2 factors of 20, which one of them is a prime and the other is a square number, if possible. So we want to break down our 20 into 2 factors of 20 and make sure one of them is prime and the other one is a square, what you guys call square numbers or perfect squares. But remember, I said if this is possible. When you think about it, what are the numbers that multiply to give us 20? And keeping in mind, we want to make sure one of them is prime, the other one is a square. So this would be 5 multiplied by 4. 5 is a prime number, 4 is a square number. Once I have my 2 numbers, my 2 magic numbers, I'm going to use the law of multiplication. So take a look at this. I'm going to start up by saying I have square root of 20. And using the law of multiplication, this is 4 multiplied by 5. I did not change anything. The square root of 20 is the same thing as the square root of 4 times 5. But the law of multiplication allows us to separate the square root of 4, right, separately to the square root of 5. So I separate using the law of multiplication. Then I simplify. You're going to simplify the parts that can be simplified, and the part that cannot be simplified remains as your surd or your root. So the square root of 4 does simplify to return a whole number 2. Multiplied by the square root of 5 is a surd and is irrational, so we keep it as square root of 5. This is how we simplify surds. I'm going to take one more example. Right? Let's say we start up with the square root of 75. The same idea. I'm going to look for 2 numbers that multiply to give me 75. 1 prime, 1 square number, if possible. Okay. When you think about it, 25 multiplied by 3 definitely gives us a 75. Using our law of multiplication, I am going to come right from here and say I started up with the square root of 75, which is the same thing as 25 multiplied by 3. The law of multiplication allows me to separate this into square root of 25, multiplied by square root of 3. Then I simplify. The square root of 25 returns a whole number 5. Square root of 3 is a non-perfect square. It is a surd. We keep it in exact form as root 3. So my solution is 5 root 3. You remember what we said in the beginning. You start up with the number square root of n, and you want the final answer to be in the form k root b, where k is an integer and root b is a surd. And we have our solution in the exact format. The 5 there represents the value of k, or k is a 5 in this example, and our root b is our root 3. We have successfully broken down our surds. Is it always possible to find this magic combination of a square number and a prime number? Watch out in the next video. I'll be talking about that.